Fellas, why don't you just show me where your guidance system is, okay? Excuse me.
He is smart.
If you've seen the last couple of my videos, especially the Hellcat one, then you know that I've been experimenting with some of Spektrum's smart technology components. Now, this was in the form of telemetry from their special receiver and avian speed controller. I've been very curious what all these new features entailed, but I didn't quite have all the equipment. Well, now I finally have all the pieces in my ashy hands, so let's take a look at the full capabilities of this new technology. Starting with the smart batteries, the first thing I noticed is the presence of a third wire on the battery plug. This clever addition maintains backward compatibility with the older EC style connectors, seen here in blue, while providing a data port for the new IC connectors. The third wire carries data to and from the battery to the smart device it's plugged into, which we will examine later in this video. The first of these devices is the XBC100 Smart Battery Checker, which even comes with an optional press-on screen protector. On one side are the battery connections with data port and balance port for up to 8 cells, while on the other side has 2 USB ports and a servo port. The smaller USB port is for updating the firmware in the device. As a basic cell checker, the XBC100 has a bright and clear display with 3 decimal places of accuracy that constantly update. Pressing the center button opens up menu options. Quite a few options, in fact. You can even balance cells, test servos, power USB device, set low voltage alarms, and set display options. System information screen gives you firmware versions and related details. Plugging in a smart battery will give you a whole host of details in addition to the state of charge and total voltage. Note the individual cell voltage is displayed even though the balance connector is not plugged in. Press the down arrow and another screen appears that displays battery details I never knew I needed. Battery state of charge displayed both as percentage and graphically. Also battery temperature. Yeah, it was hot in my workshop, but not quite that hot. Next are battery size information along with battery charge and discharge factory ratings. In this case, 3C charge and 50C discharge. More interestingly, there is logging of total number of charge cycles, over temperature events, and any cases of overcharging and over discharging. I tried to activate the balance feature, but it was grayed out and not functional without the balance connector plugged in. Instead, I turned on a USB port, which gives a neat display of power used and battery minimum voltage cutoff points. Plugging in my Android phone, I was surprised to see that it supports quick charging mode, indicated on the phone by the circle around the lightning bolt. Based on the display, it appears to be level 1 quick charging. Looking at other menu items, the backlight on high setting is noticeably brighter. There's also 4 different language options. With just the balance port plugged in, I noticed the cell voltage change colors as the battery is almost fully charged. Note the color difference with a nearly dead battery. Anyways, let's try out the balance feature. Note the background color change and clock timer in this mode. 3 hours later, the cells are pretty close to cutoff, with one cell showing red to indicate that it has the most difference. After a while, the screen will go dark to save power. So 5 hours in, the cells are balanced to within a few millivolts of each other, and the screen has turned blue to indicate it is finished. As a servo tester, it gets the job done with 2 center frequency options and both manual and automatic cycle controls. The default step count can be increased so as to speed up servo movement in manual mode. Enough of that, let's take a look at the 50-watt charger. And it's a cute little bugger. In fact, most of the box space used for the S150 charger is for the power supply and AC plug. As you can see, at only a few cubic inches, it is a pocket-sized charger. It even has a built-in cooling fan and data port for optional USB programmer. Operation is extremely simple. Short button pushes selects the charge current. while long button pushes selects battery type. It's the Macintosh of chargers. To charge a battery, just plug it in and double tap the one and only button. A 4-bar battery meter indicates charge level. Oh, and press and hold to stop charging. I was curious how much power the charger truly delivers, so I hooked up a power meter. I somehow changed to the wrong battery type, and the charger let me know with an error tones. Yes, I know. To err is human. Here, let's select the correct chemistry. Selecting the full 5 amps, stop just under 50 watts. But on a 4-cell battery, that meant no more than 3 amps charging. A 3-cell battery does indeed get you close to 5 amps, and just a smidge under 50 watts. Yay for truth in advertising! One last thing, I was curious if the smart plug included cell balancing, so I hooked up the smart checker while charging. When finished, the individual cells were not balanced, so it looks like balancing only occurs if you plug in the balance connector into the charger as well. Lastly, we have the S2100 100-watt dual output charger. It can charge up to 2 6-cell batteries at the same time. It's a compact charger with 3 buttons and a circular slider control. In the front are 2 smart connectors and accompanying balance ports, while on the back are exit vents for the 2 internal fans and a power cord connection. On the side are USB and firmware update data ports. Turning the charger on, you are greeted with a quick splash screen and then a split display for both channels. Pressing buttons 1 or 2 selects that channel as full screen. When you press the center button, you can now scroll through the menu options by sliding your finger around the circular control wheel. Without a battery plugged in, you have some basic options which can be set, which will mostly apply to any non-Smart Tech equipped battery that's plugged in. Lots of battery options are available, and cell cutoff voltages can be set, which is of particular interest to me. Charge current maxes out at 12 amps, which is respectable, but don't expect to pump that much into a 6-cell battery. Since the charger uses IC3 connectors, an optional IC5 to IC3 smart adapter is available for larger batteries. Like with the smart checker, the smart connection downloads battery info to the charger, which can be scrolled through on multiple screens. This shows a quick view of the battery stats, exceptions, charge cycles, and etc. Press the center button and now the charger shows stored battery charging configuration downloaded from the battery itself, which is actually different from the charger's own default configuration. Neat! You can even go in and edit those settings, which will be saved into the battery's electronics. I like to lower the cutoff voltages to prolong battery life. When I tried to charge the battery without plugging in the balance connector, I got a warning screen, but it will bulk charge if you override. Connecting the balance connector, I was able to get 7 amp charge rate on a 6S battery, which is about 160 watts. Okay, so if you were paying attention, you heard me say the charger is 100 watts per side. So how did I end up with 160 watts on one side? Well, if only one battery is plugged in, the charger can actually divert extra power to only the active channel, and basically double the power. I tested this by first charging a big hunk of a battery at max rate, in this case a 6S 7000 mAh battery, which topped out at just over 8 amps. When I plugged in another 6S battery and started charging it, the charge rate on channel 2 dropped down to 6 amps, while the missing 2 amps were allocated to channel 1. The battery on channel 1 is mostly charged, so it needed less amps. I also discovered another status screen that shows the internal resistance of each cell, which is very useful for detecting worn-out batteries. A long press of the center button enters the system settings, where you can change brightness and scroll sensitivity, among others. I found the options quite intuitive. Poor Germans, the words barely fit on the screen. Mein Leben! Now, one of the features that really caught my interest is the ability of the Smart Tech batteries to be able to self-discharge to a storage level voltage after a certain amount of time. Actually can be harmful for lithium batteries in the long term if you keep them at a full charge for an extended period of time. So it's better to keep them at about half charge or so, and I just want my batteries to be happy little batteries. So anyways, selecting the Smart Battery menu item pulls up the embedded battery configuration, where I can now activate and change the auto storage features. The max time is 10 days, which is too long for my taste, so through quite a bit of scrolling, I found the minimum to be 12 hours, but settled on a 24-hour start time. Lots of options for storage voltages as well. Now, I tested the auto discharge storage feature and confirmed that the time you set is when the batteries actually start to self-discharge. And I also, depending on the battery capacity and state of charge, it may take up to a couple of days to reach storage level. I also took the opportunity to lower the maximum charge voltage, which helps prolong battery life. Lastly, you can check on the exception records. Oh, if plugging in the balance cables gets cumbersome, you can get a balance extension to give you some more working room. Okay, so now that I've had the deep dive into the smart technology and the batteries and charger end of things, it's really time to tie it all together. Now I want to go on to really the plain end, and in that case I'm going to start with this. This is a kit I built for magazine review, and this is the Old School Model Works Javelin. And the power setup is actually really good, but I have a use for it in another plane. So I thought, well, okay, I'll take this power setup out and I'll upgrade it to a smart setup, which entails a new motor and of course a new speed controller. This Avian Smart ESC, which is designed to work with the smart batteries. And of course, to tie it all together, I'll have the 6-channel smart receiver. This is the AR6610T for telemetry. And so I will install the new motor, the new speed controller, and the new smart batteries, and we'll have really quite a symbiotic sort of relationship with all the parts together, and I'll hook up the telemetry in my transmitter and we will see how it runs. So let's get started. First, I need to remove the old power plant, then pop in this Power 32 motor. And lastly, hook up the speed controller. For the Avian series of speed controllers, there is a smart ESC programmer. While it also functions as an up to 8-cell battery checker, its main purpose is to be able to easily change the settings in the speed controller. For BZ-equipped controllers, there's only one cable to plug in to the programmer and ESC data port. Once powered up, the select button displays the controller firmware version before showing the programming options. Scrolling through, you have nearly a dozen options to choose from. Airplane and helicopter modes, 2 brake options, several brake force options, cutoff voltages, BEC voltages, soft start options, motor timing, I presume these numbers are in degrees, rotation direction, even active freewheeling, which I didn't know the controller had. Very nice. With everything plugged in, the last item is to activate the telemetry in the transmitter. For the DX8, just go into the telemetry menu and select Auto Config. Oh, and this time, I remembered to deactivate the variometer. A quick check shows telemetry data is indeed being received. I can now set up low voltage alerts by going into the ESC telemetry screen and setting the minimum voltage set points and activating the voice alert. While I was at it, I also set the high current warning to match the ESC's amp rating. I first used the same prop as the old motor, an 11.8. This pulled about 40 amps. but note that the nearly empty battery I used triggered the low voltage alert.
39 amps, 99 Fahrenheit, ESC 14.3 volts, 39 amps, 99 Fahrenheit.
Is it me, or does she sound British? That's one of the neat things with the telemetry. I can quickly experiment with props and batteries and see the results in real time. I can also set voltage warnings that reflect actual battery state of charge while flying instead of relying on less accurate flight timers. And all without adding extra modules and tapping into wiring. The aircraft setup is very clean and nearly invisible. 40 amps seemed a bit low for my flying style, so I moved up to a 12.6 prop and installed a nearly fully charged battery. Yes, right around 50 amps. Perfect. Though not sure why the RPM numbers are so high. Okay, so I have one last follow-up. I warn you, however, this might get a little nerdy. I freely admit that I'm a pretty curious person, and as such, I wanted to learn a bit more about the smart tech and the batteries and how that worked. So I pulled out this little guy. It's a logic analyzer for a PC, and it allows me to look at data signals directly from the smart batteries. I needed to tap into the battery wires, so I just used straight pins pierced through the insulation. Crude, but effective. With the logic analyzer connected, I took a look at the signal wire with nothing connected to the battery. Immediately, I noticed seemingly random short pulses, which you can see in the top row. I initially thought the battery may be sending out heartbeat-like signals, but I did not see them on the smaller 3S battery. Interesting. Anyways, when you plug in the battery into a smart device, a whole bunch of data shows up. And then, an unending series of equally spaced data pulses. The first burst of data is likely to be all the battery stats that get loaded into the device at first. One weird thing is a long section where the data line is pulled down to 0 volts. But I didn't recall seeing it again on any other test samples. So a quick summary shows that the data seems to use a logic low to represent a bit and typically starts with a medium pulse and then 3 short pulses. Zooming in further, I see that the pulses occur in 100 microsecond increments. Now looking at the repeating data pulses, I see they occur at precisely 1 second intervals. I'm pretty sure this is the individual cell voltage data updates. The last thing I wanted to see was what happened when I saved data to the battery. Unfortunately, I can't tell which way the data is going, so I'll have to make some educated guesses, which could be completely wrong. With good data flowing, I made a change to the voltage setting and noticed that the data is not sent to the battery until the back option is selected. Good to know. And there it is, a quick burst of data between the sync pulses. There was a small bit of data, a pause, and then a longer stream of information. After which our old friends come back every second. Again, I don't know which device is reading or writing at any point in time, but it is interesting to see a little bit of the inner workings of this technology nonetheless. Well, so this review ended up being quite a bit more involved than I had anticipated. I guess I went a little bit down the rabbit hole, so to speak. So kudos to you for hanging in there this long. But that said, I found the Spektrum Smart technology much more smarter than I anticipated. I was quite surprised at the amount of data that's being transferred to and from the batteries and what could be modified by the user. Add to that the telemetry downlink options, and you have a completely holistic system that adds great utility to RC model flying.
He is smart.